Hey there, everybody. Good to see you all. Thank you all for being here. I think this is going to be a lot of fun. We have, so this is our, the system is still allowing more people in. Give them a moment. So this is your Nature Journal Educators Forum. And today we are going to be kind of geeking out about how we might use our nature journals to deepen our understanding of astronomy and to kind of get out of this world. So I have brought on our resident astronomical expert and enthusiast, Ray Bonto, who's going to be joining us for today, who's the motivation for this workshop. Ray Bonto has been your journals are just filled with all sorts of curiosity about pigeons and all these other things, but then a fascination in space also emerged, and that has appeared in the pages of your journal. So we'd love to see what you have been up to. Also, we're going to be sharing with each other sorts of things that we have done in our journals that are astro related, and how we can do some sky watching and record that in our own nature journals. To get us started, I was wondering if you, Ray Bonto, might be willing just to share with us some of your astronomical observations and the sorts of things that you have been documenting and recording in your journal. And then we're going to be kind of, and both in terms of direct observations and theory, sort of thinking about space on a grand scale. I know that you've made visualizations of both of these. And then we want to kind of open this up for a wide-ranging discussion about what might best practices be. Anybody who's got examples in their journals of astronomical things that they have done, we want to share those, and that could be a lot of fun. Do you have some journal pages here with you that we might be able to share with us?
Yes. So clear skies are very rare over here, so I make the most of it. So one morning I was just sleeping, and then I just opened my eyes out of nowhere. It was around 5, and I just saw these like, I thought it was Venus, but it turned out to be Jupiter, and it turned out that I never ever saw Venus.
Mm-hmm.
Yeah. So I have no idea what that thing is. But the moon is still on the full.
So are you recording the date and the time with these observations so that?
Yes.
Great, because if we have those mapped, yep, then we can also look back at old star charts and be able to identify those. Interesting ways of visualizing this. I see that you're kind of creating a dark field with the with some pencil there, and then putting, is that gel pen that you've tinted?
Yes.
Ah, okay. So gel pen that you've tinted, and that's just you're laying there in bed, you see the bright object, and that's got you curious enough to jump out of bed in the morning and document and describe what you're seeing through your window. So for educators out there, this alone is huge, right? That this is you're looking at just intrinsic motivation to follow what's going on in the sky.
To tell the truth, it was too early to get up. So I went back to sleep, and a few days later I decided to put it down.
Ah, okay. So that was then a memory drawing of what you had seen. So significant enough to you then that days later, you still wanted to record it in your notebook. Okay.
Yeah.
That's significant. Like we've got these, it's crazy. You think about your place in the universe, you've got these planets spinning around that big gas ball out there, and we see them up in the sky and they're changing their places. There's this whole dance going on. Your fascination with this is also shared by ancient peoples throughout time who've been tracking the positions of those planets. That's really cool.
So, and another day, my dad just called me because there was Jupiter outside. Well, this is what we saw through a spotting scope.
Mm-hmm.
Yeah, I turned to another star, and it turned out to be Saturn.
Oh, that's really fun. And so is this, so you're looking through your telescope and sketching what you're seeing through your telescope?
Yeah. And no, same, next day.
The next day. So then doing a memory drawing the next day of what you saw on that evening.
Yeah. I decided to look at one more star, and there were thousands beside it, which I couldn't see with the naked eye.
Mm-hmm. Oh, so this is a view, sort of a deep sky view for you, where you put your telescope on the sky and you can see many more stars than you can when you're just looking with your naked eye. Am I understanding that correctly?
Yeah.
Are you able to see the red spot on Jupiter through your telescope?
To tell the truth, I don't know if it was Jupiter or just a plane, because it disappeared because I looked through my scope and I hadn't even focused it, and it looked like that. Number 2, window distortion. And number 3, after a while, it started moving a little faster. So it must have been a plane. I just realized that.
Mm-hmm.
No, I can't. No, I can't see any red spots.
Yeah. Through my scope, I can't resolve any red spot. I just see. I just see the. I just see it as this big, bright, glowing orb, but I can see some of the Galilean moons.
Yeah.
That we can see out sort of adjacent to that. Do you have any sketches? Have you ever sketched the positions of the moons relative to?
Oh wait. Well. Yeah. I have. I think. Well, I think I have. Yeah, I just forgot to. I think it's one of those two.
Okay, great.
Well, yeah. So, and one morning I woke up really early, still dark. Everyone else was asleep, no light pollution. Whole Orion out.
And you're in the middle of London town, right?
Yeah.
Oh, and so there's Orion out your window?
Yes.
And was this done later from memory, or did you get your stuff out at that point?
Stuff out.
So
at
so
that time.
that morning, while it's still dark outside, you're there, probably still in your pajamas, sketching Orion out your window.
Yeah.
Let's see, that's huge. And then later on, did you add some of those notes from other research?
No, those are just questions.
All right. That's great. So
Yeah.
what was the most interesting question that you asked about when you're looking at Orion that morning?
Yeah. So Beetlejuice was red.
Mm-hmm.
And what I was wondering was how could color photons pass all that distance without going white or something of that sort? Yeah.
So you're thinking about these photons of light emitted from the distant star, traveling through space, not losing their wavelength, so that they still come to our eye so far away and still are observed as visible red light. See, I mean, this is it. This is the kind of curiosity that that I want to see in the world, right? I want to see people sitting up in bed and pondering. You're going from looking at this star and the constellation, and then your mind is taking it to the next level of these photons traveling through space, and like, is there any attenuation in the wavelength as they're coming along, and these sorts of things. I mean, this is beautiful. This is beautiful and really inspiring. I know you also have your relativity notebook. Let's save that for a little bit, because what I'd like to do is sort of bring in more people sort of on a discussion of let's sort of think about kind of documentation of physical phenomena that we see in the heavens, and then and kind of how to integrate that with our nature journal pages. Ray Bonto, that was a really inspiring start. Thank you so much.
Thank you.
So what I'm doing now is I am looking over at the gallery. If anybody has comments, thoughts, or any comments or ideas that you'd like to share, or if you want to kind of connect onto some of the things that Ray Bonto was talking about, or if you would like to share other sort of related ideas. Let's see what's going on in your night notebook. Yes, guess I can, let's bounce over to Ivea, our co-host for the day. Thank you so much for here, and also thank you again for the work that you do helping support these workshops. I really appreciate it.
Thank you. I'm happy to be here. Well, first of all, I have to give huge props to Ray Bonto, because, I mean, you always inspire me. So thank you for that. I won't go into our discussions, but I just want to say I enjoy them so much. So thank you for that, Ray Bonto. So like Ray Bonto, I live in a city where there's oftentimes a lot of light pollution. So it can be really, really difficult to see up into space. And I don't necessarily have access to high tech like telescopes and whatnot. In fact, just the other day, Ray Bonto and Jack and Arpan were helping me figure out how to use them. So one note maybe is that if you have students, be prepared to help them with technological challenges. And I don't mean just kid students, I mean adult students too. Another thing is that something I've been meaning to do that that Heather kind of advised me on is, because of the light pollution, I thought it'd be kind of cool to create a brightness sort of guide for myself about which stars I can see on which nights, so that way I can begin to tell how much either light pollution or air pollution's in the sky. I haven't quite gotten into it yet because I was a bit bewildered by you know, where I would start, but I'm thinking the Big Dipper would be a good place,
Mhm.
depending on whether I can see, you know, 3 of the Big Dipper stars, or maybe 5, or maybe all 8 of them, because the second to last one has a little tiny little star, like a cute little mole.
Mizar and Alcor there. There's that Alcor is much fainter, and that Alcor might be a really cool way of it would be interesting to see what is the light level at which Alcor disappears.
The fact that you know the names of them makes me so happy. I didn't know the names. So little cute one is called Alcor.
Alcor. And then I think the way I remember them is that Mizar is the miser, and it's like it hogs all the light. Right. And so Alcor is kind of hanging out there with and then the other the 2 pointer stars, the pointer sisters, are Merak and Doobie.
Merak and Doobie.
Doobie.
Like Doobie. The Doobie Brothers, Doobie?
Like the Doobie Brothers.
Well done. Yeah. That's good to know. And I'm going to learn those names because that's my favorite constellation, being that that's usually the only one I can actually reliably see. Another thing is that because I don't know many constellations, and this might be something fun for you all to do too, take advantage of any black surface you have to draw on them. So my way of learning constellations is that I draw them on the covers of all of my nature journals. So this is my favorite one, Scorpion, or rather Scorpio, you know. So sorry. So I draw them on all of my covers. For example, I wanted one day to figure out Pleiades, which is within Taurus. So Pleiades isn't just 7 of them. So then I tried to write down some of the names. One thing I would say is that with kids, because it's difficult to like, you know, even as an adult, it's difficult for me to make sense of all of the complexities of outer space. I think that this is one of the big fields where words, pictures, and numbers really become important on all of the levels, because you can describe something in a text, but being able to actually draw diagrams about each of these things the way Jack does when he's explaining the moons, I think really helps. I mean, I didn't understand the whole thing about about black holes and whatnot, but I got an explanation from my friend about how it works. And so I was able to know, I didn't know, for example, that stars were allergic to iron, and that iron poisons the star. And then the way that, and this is the stuff that I could hear about, but never actually learn until Ray Bonto explained it to me. And I was able to sketch note exactly what he said. And so the way that it poisoned the star, and then the way things collapsed, and then the way that this was like the gamma ray and stuff. So like diagrams, super duper helpful. I want to say also with kids, finding ways of making it fun. So like, for example, solar system by the numbers, if numbers are scary for people, having like comparisons, having, more diagrams. I love infographics and diagrams. Here we go. Like by size difference, here are some of the moons of Jupiter and others.
And Callisto and Ganymede, they're like about the size of Mercury. I mean, moons the size of Mercury.
There's this one video I'm going to try to find. My son showed it to me, where it shows the universe like by size. And so it starts with the smallest, just like a whole big range of bodies, but then it slowly like moves up and shows one that's slightly bigger and slightly bigger and slightly bigger, until it gets to the universe, which is kind of fun. Another thing is scale. It's really hard to understand scale when you're looking at universe. So I don't know how many folks have seen the 1977 short little film, Powers of 10. Kate Rudder introduced it to me. And so that was helpful. But then there's this other thing that I saw, Wealth According to Scale, where it really puts perspective about, for example, they show you what a million is by scrolling sideways on your screen, and you can sort of see about how big that is. Then they show you what a billion is on your screen. And it's not just, twice the time. Of course not, because that's not how the proportions work. So by measuring how long it takes you to scroll to a billion, it really helps you understand scale better. I'm going to introduce that link too in a bit. So I think that that's really helpful to
that's so cool.
Get ideas of scale. And I think that that's something that opens up a lot of eyes for people of all ages. One other thing, I got inspired by our idea about zines. And one thing that could be really fun to do with your students, if you want to just get them a little bit into things, is to get black paper. This page, for some reason, I didn't get to do, but and to let them go out and just draw and make notes. This was me trying to draw the air pollution in the sky at night because the sky wasn't completely black. I could see all of this weird rainbow of weird colors. And I wrote down how it smelled too. And then questions and whatnot. So that's the thing I want to recommend, is that with your students. And then
that is next level, a little black paper zine, so that we can then be out there with, oh, I love this idea.
Thank you.
Well, and also just before you go on to other things, so you're dropping a bunch of crazy good nuggets in here. I want to point out that what Vea was saying about scale, really, really important concept in science, and especially when we are dealing with physics and the universe. Thinking about scale is different, because things when we kind of get to quantum speeds and scales and densities, everything starts behaving really differently. And from an early point, sort of thinking about the scale of the universe and things, it's this wonderful mind-bending trip. And it's also one of the cross-cutting concepts identified by the National Academy of Sciences as sort of the kind of core science idea. And so that's when you're incorporating that into your lessons. If you're in a place that's using the next generation science standards, then you're tying in with that's the scale and proportion cross-cutting concepts. They've got it's the quantity, scale, and proportion cross-cutting concept. Usually don't think about this too much when we're looking at the scale that we observe and we breathe in. But when we start thinking kind of outside the planet, this becomes really crazy important. I didn't mean to interrupt you, but I wanted to drop that in to reinforce what you were, just that when you mentioned scale, but I think that kind of tagging that is useful. Please continue, because you are on a roll and you're brilliant.
Well, thank you. And also thank you for what you just said, because you reminded me of something else I wanted to say. Speaking of next generation science standards, I think a fun way to be looking at change and constant is that, well, what's the one star that pretty much remains in the same position, at least if you're in the Northern Hemisphere? Polaris, even though it's not the brightest. So what could be kind of fun too with students is to assign one consistent day a month where they go out at a very consistent time of night, and then they try to record the position of the Big Dipper if they can see it, since it's a bright constellation. And if you do that, then you see slowly how it might change over the seasons. Sometimes our beauty hangs upside down, sometimes our beauty hangs right side up. Like, let's see here, the other night, you can't really see it very good. But I sort of tried to draw it right here, that my beauty was right side up that particular night.
Oh, my beauty. Oh, that's so beautiful.
It's my favorite. She or he or they are just beautiful. And another fun thing is, I only recently learned from my good friend Jasmine that this is called the azimuth, is that when you're taking these notes, it's also really good to note down which compass direction you're seeing the constellations in. And if you can help it, take a lesson from Jack's solstice and equinox thing, and try to see how many potatoes up a constellation is as well. So for example, one night when I was drawing the moon, I'd drawn it earlier that day. I'd drawn it earlier that day, and I drew the approximate position of where that sliver was. And then I wrote down how many degrees up, which degrees on my compass, and the time of night. Then later on that exact same night, I drew it again. You see that the sliver has now changed directions a little bit. It's not right side up. I also wrote down that it had changed colors. It's approximate in my vantage point to the ocean. And then the little friend here who was red, I think that was Venus that night, but I'm not sure. And then I wrote down how many degrees above the horizon, once again, where the degrees of the compass were and the time of night. And then I did something similar when I tried to draw who was on either side of the moon. So I was able to sort of draw Sagittarius here. I noticed that Charon was supposedly up here somewhere, which excites me because I'm really fond of that particular Greek myth. And then I know that Serpens and Ophiuchus were over there.
My personal favorite constellation.
Sorry about the coffee stain, but yeah, Serpens and Ophiuchus, they're a complicated little star pattern. I also want to take this to thank everybody out there who's been amazing. in the healthcare profession for saving us from COVID, this is for you. Yeah.
That's right. Ophiuchus is the healer.
Yeah. Yeah. So major, especially to Sibel. So all of that's in your honor. So yeah, like I can't remember. I was going to say more, but yeah, it's just, it would be kind of fun to do that with your kids, because then they can watch how things change. To have the brightness indicator for them, it'd be interesting to try to see for each of us, for starters, how many nights a year can you actually see stars? It'd be kind of a dedicated thing to have to do, but it'd be interesting to see how many nights you have that are clear and not. I'm sure I had more, but I'll say more later if I remember, and I'll give somebody else a turn to talk. So thank you.
That was a gold mine of ideas there, an absolute gold mine. And also, so I have a favorite constellation, which you mentioned is Ophiuchus, and you do too, but you get actually extra bonus points for having a pet name for your favorite constellation. And so that's next level. And so, I mean, what if we could kind of get ourselves to kind of be this way, like you've got a favorite constellation, and you get out there and you look for it, and it's just like when you see footsteps of spring again appear, the wildflower after the long winter. It's like you're seeing this old friend again, and there's a feeling of connection that you have with those phenomena. That was really, really, really fun. You mentioning the positions of the Big Dipper reminds me of sort of a related thing that you can do with that is you get you draw the Big Dipper and the North Star. So and so for folks who haven't seen this for a while, just a reminder that what we do, hold on, is that when you've got your Big Dipper, these two stars here in the bowl of the Big Dipper. So if we kind of draw some lines between these, you've got your dipper. So these two stars here, Merak and Doobie, they point to this faint star over here. That's the North Star. So if you're in the northern hemisphere, you imagine putting a pin in here. This business is going to rotate around your rotates around that North Star. So what during the summer, I often sleep outside with Carolyn. The two of us, like we have a little couch out there, and we get a bunch of blankets and we snuggle up, and we note the position of the Big Dipper, and and think of this line to it as that's kind of our nighttime clock. And so in 24 hours, it's going to do that. It's going to come. So if it starts, let's say it starts here, in 24 hours, you're going to spin all the way around, which means in 12 hours, it's going to do that, which means in 6 hours, it's going to do that, which means that when you wake up in the middle of the night, if you look up at if you notice where it is when you go to bed, you can get a sense of how many hours. So 6 hours would be 90-degree change on it. So you can use it as your little nighttime clock. And that's fun. So just wanted to tag that on to, but also like your idea of tracking that throughout the year at different times. Are there other nature journal astronomy things that folks have been up to? Let me try.
I think I also saw Joni's hand and also Rebecca's hand.
Oh, okay, great. So I'm going to bounce over to Rebecca and then Joni. Rebecca, hey there.
Hi. So this is something that I've been thinking about recently because astronomy is really fun and looking at the stars, but I think when you think about nature, or like, it's, you know, we separate things out into different disciplines. And that's why it's fun about nature journaling. We can kind of do everything, you know, but I think most of the time when you think about like nature, or at least like from the environmental point of view, it's like, you know, the biology, the living things. But I'm reading this book that I think the title is How to Be a Good Ancestor. And it's about long-term thinking, especially in terms of like how are we gonna leave behind a better world, for, you know, trying to stretch our long-term thinking into, you know, the centuries and the thousands of years, because most people never think about that far ahead. And so one thing it was talking about is like it was briefly talking about how if, you know, you want to help the environment, then it can also like almost counterintuitively help to get people interested in like either geology and thinking about like the geologic time scale, or also to thinking about the stars, because it's such vastly different time scales than we're used to thinking about on a daily basis. Like how old the stars are and how long it takes for their light to get to us. Yeah, and like you were saying with the scale that goes for time too. So I've actually been thinking about writing like a blog post or an article or something about how that, like, why the Earth needs stargazers, because I think that's something that we don't normally think about in terms of like, if you want to, like, from the environmentalism point of view, not just for our enjoyment, because it's really cool.
I love how you're thinking about this ties us right into stewardship. That's beautiful. And the book, what you said was How to Be a Good Ancestor?
Hang on, I'll go get it.
It's always weird to see people with virtual backgrounds move around the room.
No, it's just, wait, let me get my background off.
Turn off the pumpkins.
Yeah. No, I forgot. It's just called The Good Ancestor.
The Good Ancestor. Do you recommend this book?
I haven't finished it yet, but I like it so far.
Look at all those tabs in it. All right. So that's from someone who likes ideas as much as you do. If it's got that many Post-its sticking out of the margins of it, this has been productive.
I'm not done with it though, but I like it so far.
Oh, that's really cool. That's really fun. One useful constellation for thinking, or I should say asterism, for thinking about sort of time in space. When people are talking about, like, you know, this many light years to that, this many light years to that. If you're out in summertime, there are 3 very bright stars that you'll find overhead. And they each are part of different constellations. But you look up and there'll be these 3 little bright stars. So even in San Mateo down here, I'll be able to look up there and see these ones as being really, really bright. And they're what make up what's called the summer triangle. So it's not a true constellation, it's an asterism, which just means, like the Big Dipper is an asterism, it's a pattern of stars that is not technically a constellation. And the Ursa Major, by the way, the Big Bear, which is larger than the Big Dipper, that's a full constellation. Just a recognizable pattern that we see is referred to as an asterism. But anyway, this asterism is neat because but all three are very, very bright stars, but they're also different sizes and then different distances from the Earth. And so maybe somebody can look up for us here in terms of light years, distance to Vega, Deneb, or Altair, which are the three stars of the summer triangle, and drop that into the chat. The light year distances to these are really interesting. And then you can compare that with the size of the star, right? How many suns that is. So that's a fun thing to track during summertime. And then if you just want to kind of geek out on thinking time in distance, it's a useful thing because all of those stars are incredibly, very, 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 very different distances from the Earth. But you have the sort of subjective experience of it just all being this one sheet because our depth perception doesn't go out that far because our eyes are only this far apart. Rebecca, thank you so much for those comments and thoughts about sort of kind of thinking about time and tying that into our responsibilities. You know, it reminds me of when we talked about those international school key questions. One of their questions was, what is my responsibility to this? And that kind of your good ancestor idea ties us into that in a beautiful way. Avea, you had another thought that you wanted to share.
Yeah, Rebecca reminded me. Well, speaking of like responsibilities and also about how different cultures might seek responsibilities, it could also be really good with students to connect different star stories. So, for example, I know that I'm most familiar, for example, with Ursa Major, Ursa Minor, and learning the whole story about Callisto being flung up there with her son to make the bears. But it would be interesting to look at other cultures and hear what star stories they might have, because I know that they're probably different. Or like I remember hearing that there is a particular shape, a negative space shape, or maybe not exactly negative space, but you know what I mean, like a darker space shape within the Milky Way that I think to the Inca was looking like a llama, if I'm remembering rightly. But that if you look at the Milky Way, you'll have different shapes that people spot. It would be kind of cool almost to liken it to like cloud watching and seeing what different people see, or having kids create, or like having kids create their own star stories. So a way to make it so that's not just about technicality and science, but like to tie into Rebecca's restoration class, which I can't emphasize enough. Everybody should take it next time she offers it. Create your own stories around those stars. That makes them mean so much more to you, and it makes it so that you remember things a lot better. You get like something that Rebecca says, and I know she was quoting Jack as well, like something you both say is that by creating a story, you're connecting what's new to you, which might be stars or a constellation, into something that you already know, which is the feeling that the story produces in you. And I emphasize, I get that wisdom from Rebecca and Jack, so please take restoration. Okay, so that was what I was going to say.
Love it. Let me show you just a couple of things in my journal that I've been geeking out with, things that are really, really fun to do. Let's see. Of course, when we kind of get into times when we have something like a comet blasting by, we can get out and draw those comets. But as Avea was alluding to, it's one thing to have to say like, here's my drawing of a comet, and its tail is this long, and for scale I can put in a few other stars. It becomes even more interesting though if I bring in time and watch the progression of this over time. Whoops, we gotta go here. All right. So just like in your journal, recording the positions of the Big Dipper at different hours of the night. And you can also look at something like a comet at on different days, and you're going to have different lengths of the tail, and it's also its position relative to the background of stars is going to be different. Another phenomenon that is interesting to track are just are kind of conjunctions of planets. So there'll be times when you look up in the sky and you'll see several bright objects lined up, very, very bright, evening objects. There are times when, as we're moving around the sun, from our position on Earth, the positions of the planets appear to get closer to each other. They're not physically getting close to each other, but from our position here. And these are fun to track because you can then also, if this is night 1 and then this is night 2, how do those change over time? Or maybe this is night 12, right? How fast do they change, and how does that change over time? Which ones are moving the fastest relative to each other? So you're going to see that planets actually move at different speeds relative to the background of stars. And the further the planet is from the sun, the longer it takes it to move across its little arc there. And the closer, so the distance from the sun and also the your proximity to Earth. So things like Mars, that is really close to us, does a lot of movement through the sky. Mercury was even faster. Something when you're looking out at, say, Saturn against the night sky, its position night to night is going to be more constant. So you can get changes in those. And there's another fascinating thing. If you are tracking, let's say this is you have a map of all your stars here. And what you can do is over a series of months is look up online when different planets, and particularly the ones that are visible planets. The visible planets that are the easiest to do this with are Mars, Jupiter, and Saturn. So Mercury and Venus are also close to us, but they are so close to the sun that they always set really close to when the sun goes down. But with the ones that are outside of our orbit, you can have a lot more fun with those. So, but look for when those planets are what's called in retrograde. And this is, and then, so let's say you're tracking the position of a planet, night after night after night, or week after week after week. What you're going to find is that there are times like the planets are going to move, and then they're going to sort of appear to slow down, and they actually reverse their direction. They go back the opposite way. And then they slow down again, and then they come back, and they keep kind of proceeding as they as they were going. So there's this apparent shift in the direction of those planets. And the reasons why is kind of takes some geeking out with sort of realizing that you're looking at a thing that is moving while you are on a thing that is moving. So it's actually wonderful evidence that the Earth is actually moving as we are observing these other planets. So looking for things in retrograde is another really cool thing that you can document in your nature journals.
we've talked before about solstices and equinoxes. So this is looking at the sun doing those sorts of those movements. I'm also now starting to kind of play with the moon. And so this was for International Moon Day, which is something that I made up. I decided about a month ago was International Moon Day, and I tried to get everybody to make lunar observations on the same month. And then we would compare the angle of these across latitudes. So there's a recording of a class that that you can check out, and where we're kind of looking at the angle that you see the moon at is actually different depending on your latitude, north and south. And so another point, just like we compared across latitudes with this, I am going to try another version of the moon observation, but I'm actually going to try to do it during the day. Here's another kind of thing that I've been kind of playing with. This is on October 12th at different times. This is the angle of the half moon in the sky. And the moon, as from 5:30 to 8 o'clock to 10 o'clock to 11 o'clock, that angle of the moon was changing. And so that's another thing that we can document, observe, and then geek out on about what's going on. There's always just a little bit more going on than we think, right? So those are some other kind of fun things that we can play with. Let me turn this off. Is there, and if anybody else has, actually, first I'm going to point something out, and then about this page here, something that was really fun is that just, you know how nature journaling together is such a cool experience. So on this night, Ivea and I were actually having a phone call as we were watching the moon that night. And so this is a little diagram of Ivea, who is sitting on her roof, and me out by a little marsh with my scope, kind of. So I put whatever's significant into my journals, and just sort of being there with you through the telephone made that so much more fun.
I totally agree. I had just like the best time with you that night because then we were able to compare when the clouds were covering up the moon, or who could see the moon more. And it was kind of interesting that sometimes the similar clouds would cover up the moon for each of us. So, and just like hanging out with a friend, that's the best. So thank you for that. That was really fun. I wanted to mention, I know Joni had her hand up earlier. So I wanted to make sure we got to Joni.
Let's bring her in. Gallery, and Joni, thank you for being here.
Thank you. I just wanted to share, Yvette mentioned earlier, last year on the winter solstice in 2020, I journaled the Jupiter-Saturn conjunction, and that was the closest conjunction since 1623, and the closest observable since 1226. The year 1226, and it won't be matched again until March 15th, 2080.
Wow.
It's not real easy to see because they were small. I just did it from the naked eye, although I used my scope.
Look at this.
The thing that made it even
really
more
fun conjunction.
The two planets were actually 456 million miles apart, but they looked close.
Yeah.
It made it nice. My niece, who doesn't usually have any interest in nature, really, she came and joined me to see it. So, but in the process of us sharing and all, I had another, I thought I'd share this and people may be aware of it. We're talking about stories. This is a really good book, Keepers of the Earth. It's a Native American. And it divides it up in, the table of contents shows it as their sky. It breaks it up into the seasons and it pulls stories from various groups. So if anyone's interested in that, it's a really nice book to share with people and children especially. This was a favorite book of mine when I was in elementary school. It's a great way to learn your constellations and the stars, and it goes over the seasons. And
I was looking for my copy of that and wanting to find an excuse to kind of, Ray Bonto's holding his copy of it up. Yeah, folks, this is the best book on learning constellations. Yes. And it is interestingly by, does the name H.A. Ray ring a bell to anybody? So put in the chat if you know who H.A. Ray was. Where have you heard that name before? Yeah, that's the person who gave us Curious George, is an astronomer and wrote the best book to help you kind of learn and identify constellations. Because you can draw the lines any way you want. The way that H.A. Ray chose to draw them is learnable, rememberable, and really, really useful.
Yes, this is.
Yep. So, you know, the Gemini actually looks like two little people kind of holding hands. That's great.
This is another great book. I'm sorry.
Well, you mentioned Keepers of the Earth. The same authors wrote another book called Keepers of the Night, which is entirely nocturnal activities and stories.
Correct. Yeah. This is just one other nice book to learn. 365 Starry Nights by Chet Ramo.
Write that down.
It takes each day, like this would be July 19th. And it takes one topic and discusses it. May give the background on names and the mythology, and it talks about the various stars. And also it's another great way to learn your books, or your constellations and stars. So on.
Oh, that's really useful. Thank you.
Yes, you're welcome.
So so a couple of other just logistics. If you are doing star journaling, for your headlamp, get yourself a piece of red acetate film and put that over the lens of your headlamp so that you're casting a sort of deep red color. If it is not thick enough a red filter, if you're still able to see colors, your filter is not really red enough, right? It's not dark enough. You want to have a red filter that prevents you from seeing colors. And what this does is it saves your night vision while you have a light on. So anytime you turn on a light at night, then you've got, I think it's vitamin A and the chemical opsin in your eye. And those combine to make rhodopsin, or visual purple, a chemical in the presence of which your rods will fire under lower light levels. But in the presence of light, those separate back into vitamin A. By the way, eat your carrots. We call mini carrots in my house the night vision pills. Like, I'm going to take some night vision pills, and then my daughter's like eating carrots all the time, right? So because vitamin A is one of the components of this visual purple pigment, right? So to prevent those from separating back out, if you have the red filter over your light, then you're not blasting your color vision. So that means it's difficult to work in color because you can't see color, and that's okay. But that's a strategy that a lot of astronomers use for looking at objects in night. You also would be surprised to find out how well a just bird watching spotting scope works for looking at planets in the sky. So you can see the moons on Jupiter, or at least 4 of them. There are 4 moons that you'll typically see, which are large moons, and they are. It's interesting. They're all named after mortals who had the unfortunate opportunity to have a romantic encounter with Zeus. And so Zeus was notorious for Zeus got around. And so Io, Callisto, Ganymede, I think Europa is the other. Is that right? I think that's right. The other, there are these moons, and you can see those just in a little line out from Jupiter. Track those over night after night after night after night, and if you put them all in a row, then you'll be able to draw sine waves through them and figure out which ones are in the closest orbits, which ones are in the furthest out orbits. And that's another cool activity to do. So those are some strategies for using your nature journal with night watching. To bring this home and wrap it up, let's just drop back to Ray Bonto, who's going to get theoretical with us for a moment. And let's take a look at Ray Bonto's relativity notebook. And as you do, I would like you to think about the power of starting to draw not just what you observe, but ideas. And how will that change your perception? So you ready, Ray Bonto?
Okay, so so I was reading this book some time ago, and it talked about time slowing down. I couldn't understand it a bit, so I decided to go into it a bit. So what I found was that space and time are the same thing. I don't know how Einstein got it. That's the next thing to find. But so as a result, if you go fast in space, time will slow down. So
I love these clock icons where you're showing that the one that is earthbound, you don't have as much movement in that, and the one that is in that rocket going around, the clock has not moved as far.
Yeah.
So, yeah.
And that's about it for special relativity. General is mass bends time. If you think about a rubber sheet, put a metal ball in the center. It'll make a dent. Put, like, for example, something less dense. I don't know what. Um, and put it beside it. And you'll notice that if it's dense enough, it'll make another dent, but it'll keep following the, it'll keep orbiting the denser material because that has a deeper dent. You know what
Yeah.
Yeah.
As long as its speed is able to keep up its speed, it'll then be in orbit around.
But if you put a plastic ball, yeah, but if you put a plastic ball, something that's too less dense, yeah, it'll just go in. So space is the same thing. I mean, space-time. And
are there any sort of journaled notes that you could show us that as you're thinking about these ideas, they don't have to be something that is kind of a clear infographic of those ideas, but just as you were playing with these thoughts, that be really curious to see the kind of marks that you put to paper. Oh, you are currently muted.
Sadly, I must have forgotten to put that in. So, but you can look it up yourself. Or space-time diagram, that's it. But so if you, it's the same thing. If when an object gets denser, its dent in space-time will go deeper, and more things are likely to go in. So until space-time breaks at a point, and that's a black hole, and nobody can escape it. It's like a waterfall, but it's like a well. It's like a waterfall where people can row at the edge and escape, but when they're inside, there's nowhere out.
Once you pass that critical point, it's not going to be a good trip.
Yes. There's no time.
The boat near the waterfall analogy. That's useful. I like that.
Yeah. And suppose you take a clock, and you go into a black hole. When you go inside, you'll see that it'll never change. So not because it's broken, but because time does not exist in a black hole. So yeah.
Well, these ideas, these kind of wonderful visualizations, are great things to make these sketch notes of and to sort of explore those ideas. A lot of the thinking that Einstein did, part of it was with equations, but Einstein led with visualizations. And so the more that you can try to visualize these things yourself, and to try to put those down on paper, then you are, you're getting, you're trying to figure out like how can you, how would you go about visualizing that? Those are wonderful exercises. So Rebanto, thank you for sharing your relativity notebook with us. I love it that you put that together.
I don't know if any. Did you manage to understand?
Well, we're not. Nobody expects you to give a full comprehensive lecture on curvature of space-time. That would not be a very. But what I was interested in was that you were excited about this enough to start journaling and documenting your ideas as you were learning about it, and that kind of visualization, so you've got your curiosity that drives you to do the journaling helps you understand and retain that information. So there's a wonderful feedback loop that happens between those. And it's exciting to see your excitement about both the ideas, but also about you're experimenting with representing those ideas on your piece of paper. So I appreciate you sharing that with us.
Thank you.
Thank you. Hey, Arpan, good to see you. So I'm going to bounce over to the gallery, find out if there's anybody else that has any other final comments, thoughts, or ideas to share about getting astro-wise with your nature journal. I really appreciate people's thoughts and suggestions. And we've got some new books that we might want to check out. We've got some ideas here that can inform both our own personal nature journaling and some things that we could do with students, so that when we're out kind of engaging with stargazing, there are concrete things that they can observe and do that helps them kind of understand their place in the universe. Want to just remind you again that your nature, Ray Bonto was just talking about the curvature of space-time, and that your nature journal is actually the best tool that you have for time travel, because you're able to hold a moment in time and then compare that with the next. So if you sketch the position of, say, the Big Dipper, and then you draw it again 2 hours later, they're able to look at what it was, what it is now, and that, or over a series of nights, sort of see the progression of a comet, or over a series of a month or so, to be able to catch a planet in retrograde. Those are all wonderful things made possible by the time traveling ability of the nature journal. Folks, thank you so much. Thank you all for being here. And I hope that you got some useful strategies and ideas for your own classroom or your own journaling process.